Let's talk about ER diagrams. To understand ER diagrams, first of all, you should understand where do we use it and what is the purpose of it. So I will tell you, generally, first of all, we start our story at, a person who wants to have tables. That is the starting point. So there is a person called Raju. Raju wants to create, otherwise Raju wants to have some tables to store his information, but he doesn't know how to store it. Then designer comes into the picture. Okay, otherwise DBMS expert. So this DBMS expert is going to collect the information because he is going to store the data on behalf of Raju. Then this, let's say, call him Rakesh. Then Rakesh is going to collect the information. But what is the way of collecting the information? Because he is a person, he is going to give that information informally, maybe in his mother tongue, otherwise in English, whatever. So whatever the form he gives, so we have to collect it. Once you collect it, this is called requirement analysis, otherwise requirement collection phase. So we take that, all the data, whatever it is given by him. Example, how he give, I will tell you. We'll ask Raju, like, Raju, what do you want? Actually, I want to create some two tables, he will say. Otherwise, I have some, two kinds of data. One is, we have employees and we have departments, and we would like to store employee information. Then you just ask him, so employees, what kind of information you want to store about employee? So if you ask that question, he will say employee contains, let's say, names, and he will say salaries, maybe age field, in that way. So slowly he will explain what are the properties of that employee, correct? So it depends on his requirement. So whether employee should have salary or not depends on his company. If it is a startup, then we don't require salary field. So I'm just kidding. So similarly, finally, Raju is going to give us ultimate data, right? But for that we have to ask a lot of questions to him, whatever it is. So slowly he will give us data informally. There is no form for it, I can say, correct? So we have to convert into right form. Before converting into right form, if you directly create a table, then what happens is modifications will be difficult. You don't understand, and it is very difficult to directly convert from this informal notation to, or informal description of tables to physical, otherwise logical tables. So we will see that later. Before that, we need a sophisticated model which is going to be used to convert his informal description to one good description. That means a good model, that is ER diagram. So here ER diagram is going to play an important role. So when you use ER diagram, it is easy to collect the data from him, and it is easy to us to put all the restrictions and all the associations which are given by him. That's why we prefer ER diagram. We will see why this ER diagram is very easy and very convincing. To understand, first of all, we should understand what is ER diagram, how this ER diagram is going to represent his informal description. We will see step by step. So first of all, we'll see one typical idea, like, generally if you ask Raju, so Raju says what? Raju says that I have employees and departments, you have to store the data, correct? Then immediately what comes to our mind is, so employees are like, some set of objects, I can say, correct? Similarly, departments also, like, if you see, whenever he said departments, what comes to your mind? Every department will have, so if you imagine, every department will have some identification number and location, everything, right? So we'll ask him, like, do you think that, department has location? He will say. Should we store address of the department? He says yes. And do you want to store phone number, anything related to the department? He says no. That's why it depends on Raju, like what to store and what to not. So that's why he is going to, through his, by asking a lot of questions, will understand what he wants to represent. That's quite easy thing, right? So this is what we are going to do. Now how I am going to use ER diagram to represent whatever he gives. We'll see slowly, one by one. First of all, in high level, if you see, Raju is going to say that I have some objects or entities. That's why first in ER diagram, we are going to represent entity. What is entity? I will tell you. Entity is nothing but one, distinguishable object in the world, I can say. Example, in this problem, like Raju's problem, so Raju has two important entities. What are they? One is employee, second one department, right? So we'll try to understand employee entity and department entity. And what are the things these employees and departments are going to have? So first of all, we mathematically represent this employee. It's a set, correct? Collection of objects. Now in employee set, What can you imagine? So in employee set you can see employee 1, employee 2, employee 3. Surprisingly, all these employees will have names, right? All these employees are going to have salary. That means all this collection of, this set will have common properties. That's why whenever you have entities, then what comes to your mind is every entity will have some unique features. That is nothing but attributes. Now we'll see the features of employee. So they are nothing but attributes. So we'll just try to understand, because it depends on, again, the user's requirement. We'll ask, Mr. Raju, your employees will have some properties, right? Please describe. Then he's going to tell us every employee should, have name. Okay. Then every employee should have ID. That's quite obvious. Even as a designer, I know that. Then we'll ask more. Raju, do you have any extra features for employees? Then he says that then my employees should have salary. It's quite obvious, like every employee will have such kind of salary, right? In that way, slowly he will be explaining all the properties of his employees, because it is his table, right? Similarly, we'll ask about department. What are the properties you want to have for this department? Then he will describe department. Every department will have some address, otherwise unique identification number, department ID, and every department should be named department name for easy access, and every department should have address. In that way, all the properties he will mention. From now onwards, let me erase Mr. Raju. So however, Raju is going to give us all this information, but we just eliminate him. So we just think as a designer perspective. That means we are going to collect the data, and but without him we try to discuss these things. So finally, employee will have employee ID, employee name, salary. Department will have these properties, correct? So these properties are called attributes. Now we are going to represent, because see, this is essential information I would like to store, correct, in my computer. Before that, how to store it? In ER diagram, we store them in this way. That means whenever you have an entity, in ER diagram how we store is, we see that first. Forget about tables, everything. We are not dealing with tables now. We are just dealing with objects. So employee is an object or entity, and collection of employees is called entity set. So there are two things, entity, second one entity set. What is entity set is, what is entity, right? So entity set is nothing but collection of similar entities. Similarly, so we know what is feature, right? I'm using a keyword called feature. Feature, otherwise attribute, right? What is attribute? Attribute or feature is nothing but, I can say, which is uniquely identifying one entity, correct? So to differentiate to employees, we are going to use features. Otherwise, to describe an entity, we use some features. That's it. That is about attribute. Okay. So attributes, otherwise I can say attributes are going to describe an entity. So now these are the attributes. That's it. Today just we learned what is entity, correct. Second one, what is an attribute. Let's focus on these attributes. There are various kinds of attributes possible. We'll ask Raju again. My dear Raju, what kind of attributes you have? Everything we will ask. So one kind of attribute is, these attributes can be single valued attributes. Second one, multi-valued attributes. Of course you know that, that's why I'll quickly give the idea. Single valued attribute is an attribute which takes always a single value. Multi-valued attributes generally takes multiple values. So let's try to understand what is example of single valued attribute. Obviously, age is a single valued attribute, right? Definitely. Everyone will have only one age, right? So single valued attribute. Now tell me one example, which one is multi-valued attribute. If you don't understand, that means if you don't get the idea, stop the video and think about it. So multi-valued attributes are phone numbers. That means nowadays everyone is having multiple phone numbers. That's why one is phone number. Second one, addresses, right? Temporary address, permanent address, correct? So address field, I can say multi-valued, and phone numbers also multi-valued. In that way, so many examples are possible. Now there is other classification of attributes, that is composite attribute and simple attribute. Simple and composite. So because in normalization already I taught you what is composite attribute, what is simple attribute, right? So simple attribute is nothing but we cannot further divide it and understand it. But composite attribute can be seen as a structured attribute. That means you can again further split it into some parts and we can understand it. Example, address field again. So don't get confused. Address field is multi-valued if you want, and at the same time composite also. It depends on our discussion. So if you store multiple addresses, that will become multi-valued, and whenever you store address, and though you though you fill multiple values, see one address how it looks like. Example, 288 Doan's Colony, Hyderabad. If this kind of address if you store, then there is a structure, right? Door number and colony name and city name, right? So every attribute, if it has this kind of structure, we say that it is composite attribute. I can divide this attribute's value into three parts. Still I can understand some meaningful information from each and every such I can say component, correct? But if it is simple attribute, we can't further divide it. Example, if you have, let's say, age. Age is a simple attribute again. Example, someone's age is 25. Can you split it into two parts, and can you understand anything about 2 and anything about 5? No, that's why it's meaningless, right? So such attributes are called simple. But these two are not mutually exclusive. That means an attribute can be multi-valued at the same time composite. And an attribute can be multi-valued and simple. An attribute can be single and composite. Anything is possible. These two are quite independent. Now we'll see derived attribute and key attribute. Derived attribute is like this, very simple. You have, let's say, date of birth property of some employee. That means you know the date of birth of an employee. Then we can derive another attribute, that is age. So whenever you know that date of birth is like this, 10, 6, 2000 something, otherwise 1990. So whenever you know this date of birth, then we can say that age is, so just currently it is 2016, right? Then it will be 26. In that way easily we can calculate. So based on date of birth, if you can calculate age, then we say that age is derived attribute, and which can be derived from age, date of birth, correct? But if you know the age, can you derive date of birth? No, right? But year can be derived. So that's why such attribute is called derived attribute. Next one is key attribute. You know what is key attribute? Candidate key. Minimal set of attributes which can uniquely identify all the other attributes. Generally, when you have employee entity set, in employee entity set, what will be key attribute? Definitely one unique identification number is required, that is employee ID, correct? So this is key attribute. So I don't want to discuss key attribute because you are much aware of this key attribute. Now we will see how to represent all these things whatever you have learned in ER diagram. Before that, how to represent your entity in a set form, that means in mathematical model. First of all, this is the way you can represent your any entity. Example, I have an entity called employee. For simplicity, we take only two properties of that employee. One is employee has employee ID, second one employee name. When you have such entity, how you represent in mathematics as a set? Simple, ordered pair. Employee ID 1, employee name Raju. So 2, Rani. 3, Rakesh. In that way, we can easily represent any entity using set. Now that is the story. So each component is nothing but an attribute, right? So now we will see ER diagram for that. So in ER diagram, so two things we are going to represent now. How to represent entity, how to represent attributes. These two just we learned, that's it, right? So we will see. First of all, whenever you have entity, so write a draw rectangle box and write that name of the entity inside the box. That's it. Now whenever you have an attribute, we use oval to represent it, and we connect this oval to this box through line. It is very easy to understand. So this is the way usually we write attributes. Example, employee ID and employee name. Now we have different types of attributes, right? How to represent, I will tell you. If it is multi-valued attribute, then please underline, you write two ovals. Okay. So example, one of such thing is, let's say, probably phone number. Whenever you have phone number attribute, then what we do is we write one more oval, and two ovals are required. Now second one, how to represent derived attribute. Whenever you have derived attribute, we don't keep oval. Example, age, right? So we write like this, dotted lines. Usually whenever I write dotted oval, that will be derived attribute. Now we have to cover what is how to represent this composite attribute. So composite attribute will be represented like this. Let me show that. Example, address. So this will be like this. Address. Again address will be further divided like this. So we can use this one. Address in that. So first of all door number. Second one, let's say street name. Third one is, let's say, city name. In that way further we can classify this composite attribute. So this is a representation of composite attribute. So finally you understand so far how to represent entity and how to represent all the different types of attributes. And final thing, sir, what if it is key attribute? How you represent? Generally key attribute is underlined in the ER diagram. In that way finally slowly we are learning how to represent which are things. Otherwise I can say that how to represent objects and their features, everything through ER diagram. Now we will come to one more important thing, that is sometimes what happens, these entities are related, like in the real world objects are related, correct? Similarly in databases also these entities are related. How they are related? They have some relationship. So we are going to represent that relationship. Example of such relationship I will tell you. These entities, employees are entities, right? These employees are going to company, right? Maybe they are working for some departments. So that's why employee entity, and department is also an entity because department has some features, right? What are they? Every department will have department ID, department name, same story, correct? So now finally I can say that you have employees as entities, correct? And you have another entity called department. So these two entities are actually related. So yes, in ER diagram we can represent the relationship among the entities. That is through, of course, rhombus. We will see that later. Picture doesn't matter, but we try to understand. So what kind of relationship they have? Every employee works for a department, correct? So I can say that employee works for, simply I don't write exact diagram first, I write like this. Employee works for department. This is not ER diagram. Just I was showing some, it's just pictorial representation I can say. Okay, so employee works for department. We will see how to represent this kind of relationship using ER diagram. Okay, example, you have some students and every student is going to enroll for some course, then that is the relationship between them. Then how you represent it, we will see. So here what is the information I would like to store is, I write in first of all text form. Student is going to, so student enrolls for, I can say student enrolls in a course. So we have to represent it. So by seeing this line, this is given by Raju, the person who wants to have tables. So we'll try to understand. Oh, student is something entity, I can say, correct? So what I do is I create student entity. We know that in ER diagram we can represent it like this, student. Then what are the unique features we can have for student? Maybe we can collect them, we can ask him. Then he said student ID is one feature, then I put underline because I know that it is key attribute. If I don't have clarity, then I'll ask Raju, the student ID is going to be unique? Yes, then he will say. After that, then we'll ask, every student will have student name, right? Yes. From now onwards I don't discuss that thing, so we'll just ignore Raju, and we know the features, right? Generally, let me write some of the features this time. Student ID, student name, let's say every student has age. Okay, so that, and one more thing, since you are not writing date of birth, then age cannot be derived attribute, correct? That's why simply I put oval, which is not dotted. When you have date of birth, then age will become derived, correct? That's why here it is not derived. Now in the previous picture also I think I did not add date of birth, so if I add date of birth, then only that is, this age will become derived attribute, just remember it. Now, so this is about one entity called student. Now student enrolls in a course. When student enrolls in a course, then what is course? Course is something like, course will have some of the things, right? So course is nothing but, generally think, course is an entity. Why? Because course also will have some features, correct? How to describe the course? Every course will have course ID, correct? See, next, every course will have some feature called course name, and let's say every course will have something duration, correct? Maybe how many months this course has to be taken, correct? So we'll have duration. We can have course duration. If every course has a fixed duration, if depends on student, then So if that course duration is going to be depending on student, then that will be separate story. At this moment I am assuming that, let's say, this duration, every course has a fixed duration where whoever is a student. Okay, if that is the case, then how we are going to relate them, we'll see. There are two entities now. What I want to say is, these student and course are actually related things, correct? So this student is going to take some course, right? So how to represent that? So using the relationship we represent, especially in ER diagram, whenever you have a relationship, we put it in rectangle like this, otherwise rhombus. So we take one rhombus and we connect these two rectangles to this relationship. What is the relationship they have between student and course? Student actually enrolls for, that's why this enrolls represents relationship. In that way, whenever someone gives us some informal description, we can get, attributes and entities, relationships, everything. So this is relationship. Now my question is, sir, how do you know that enrolls is a relationship? Because usually entities are not, they are not relations. Relation is nothing but, I can say, which connects and which likes to connect one or more entities. Here student and course are having some relationship. So to record it, we have to bring something into picture, that is actually relationship. So enrolls is a relationship that is different from entities. So entities are individual objects, they are independent. But relationship is not independent. That means we can't imagine enrolls without students and course, correct? That's why that is relationship. There is a difference between entity and relationship. Okay. Now, so sometimes relationship also can have attributes. They are called descriptive attributes. Descriptive. So we'll see what is an example of descriptive attribute here. So student enrolls for a course, and duration is, of course, it's a course property. I can say that student, let's say, enrolls for a course, maybe it depends on the, so sometimes there are two possibilities. One is online, offline. So a student can take online course, same thing he can take offline also. Let's say there are two possibilities. Then this enrolls will have that property, that is student can enroll for a course offline or online. So that attribute name is, what is the type of the course? That means what kind of what kind of enrollment you want, online or offline. So I can use type for it. Understand? So this type will be yes or no kind of thing. Sorry, online or offline is the data in type. So doesn't matter. Finally, this type cannot exist without this enrolls. Otherwise, without student takes a course. Correct or not? Example of such data we'll see now. We try to, so we know that student is a entity set, we can represent as a set form. Course also can be represented as a set form. Then we try to understand this using mathematics now. So student can be imagined like this. I don't show everything. I show only these two. So in mathematics, we can represent this entity like this. 1 comma A, right? 2 comma B, right? 3 comma C. So I'm missing intentionally age field. Now, how to understand course in mathematics? It is an ordered pair. I'm ignoring again duration. So course ID maybe, I can give 001 and course name C, right? 002 and C++. So many things. Here course ID is unique identification number that is mentioned by the Raju, who is nothing but owner of these tables. Right. Now how to record relationship? If you represent entity as a set, how you represent this relationship? We will see. Generally imagine. So we will be representing like this, I think. Tell me, how can you say that someone enrolled, some student enrolled for course? There should be. How to record it in mathematics? Simple. It's a Cartesian product, I can say. Correct? Otherwise, it will have 4 attributes. 1, student 1 and his name A. Correct? Then he is going to enroll for a course 001 and course name is C. In that way, we can record enrolls information. So enrolls also can be mathematically represented. Understand? This is ER diagram representation. This is mathematical representation. But however, we know that 1 means A, I can ignore while showing. Correct? 001 means C, then we can ignore redundant information. Right? Essential information is 1 comma 001 and C. Type also important. If you don't mention type, can you say what is the type? Is it online or offline? So 1 comma 001 and the type is online, let's say. Okay. So in that way we can record relationship. Second one, 2, let's say enrolling for course 002, but he is interested in offline. So this is the data, typical data related to enrolls, and this is the data related to student, this is the data related to duration, correct? Now I can say that this, what can you understand from this one? It is nothing but combinations of this data, I mean this tuple and these tuples, correct? But they are properly mapped tuples, correct? Not a Cartesian product, but in Cartesian, but this data comes from Cartesian product, right? So this is about representing some relationship. To represent relationship, you need entities, correct? And one more thing. Here, this relationship can be, this relationship can have multiple properties or multiple conditions. We'll see one by one. So what kind of conditions this this kind of relationship will have one by one. Let us see what is constraint. That means we can put some constraints on this relationship. They are mapping cardinality, second one participation constraints. What is mapping cardinality? I will tell you with one example. Example, let's say you have some employees, let's say, and let me take essential features, not more than that, so that it is easy for us to quickly grasp the things. So let's say employee is working for some departments. So here we use works per relation. So this is relationship, works per department. Let's quickly write the properties, otherwise some of the attributes of employee. Let's take minimal attributes. One is employee ID, second one let's say employee name, not more than that. So employee ID is a primary key, otherwise key attribute. Now here department contains department ID, key attribute, department name. That's it, enough. So now I would like to ask one employee, Mr. Employee, so you are going to participate in this relation, I understand. Maybe this works for can have, it is not compulsory. Remember one thing, your works for relationship might not have any features. Example, without writing features also we can represent relationship. It's not compulsory. But for fineness, that means if you want to have more clarity about the data, we can have properties generally. So maybe one employee is working for some department for some duration. Okay. So example, let's say Raju is an employee. He is working for a department for 1 year or 2 years. So duration is one of the attribute which is descriptive attribute which exists only with relationship, correct? That means it's not a property of an employee. It's not a property of department, but it's a property of, when employee works for a department, then the property automatically pops up, right? Now that's why duration is compulsory a property of works for. Now we'll ask this employee, my dear employee, for how many departments you are going to work? So generally every employee works for one department, right? That's why every employee is going to work for department. If you see the data in the works for, you understand. Example, let's say this is employee information like 1 comma A, 2 comma B, so on, right? So this is department information. Let's say department 001, department name something X, department 002 and Y. This is the typical information about department. Now if you see the relationship, you understand. In relationship, how what will be the data? See, so I do one thing, rather than recording the relationship as again a separate set, let me show that as a mapping. That means I am going to map now. So this entity with this entity. So 1 comma A, let's say really it works for 1 comma A works for 001, then we map like this, like this. So since we have a duration, maybe we can write here 2 years like this. So this is the way we can record mathematically relationship. See, relationship is a mapping, correct? We know that. Similarly, let's say 2 wants to work for 001 for 3 years, we write like this. So 2 comma B is working for 001 for 3 years. Similarly, let's say 3 comma C, right? Let's say he is working 4 years in department 2. So this is the mapping. Now by seeing this mapping, we can say about mapping cardinalities. That means to understand that, we can ask this question, each employee is working for how many departments is the first question. If one employee, see here each employee is working for only one department. That's why in this mapping you have only one edge between 1 comma A and something, correct? Sometimes what happens, if you see from 001, if you see this side, so there are lot of edges. Why? Because this 001 is attached to so many employees. That means every department has multiple employees. That's why you get this kind of picture. If one employee works for so many departments, you get this kind of edges again, correct? So this kind of relationship in mathematics is called dash, one to many or many to many or many to one or one to one. See here. So it is definitely one is mapped to many or many is mapped to one. Definitely it is many to one relationship, correct? So many are mapped to one, correct? But if you see reverse, then every department is mapped to many. So one department, see, one department mapped to many. Many employees are mapped to one. That's why this relationship type is many to one. Similarly, we can understand many to many, one to one, one to many. We'll see one more example and we quickly see what is the mapping cardinality. So finally, you understand mapping cardinality. There are four types of mapping cardinalities. They are one to one and one to many and many to one and many to many. So this mapping cardinality is one of the essential feature of the data. That's why we are going to record in ER diagrams and we are able to record it also. We will see that. So whenever you have many to one from now onwards, how you represent it is, so one side, see here, let me write first of all many to one, correct? Whenever you have many to one relationship, we keep one side arrow like this. So many side as it is, this arrow, simple arrow, but sorry, simple line, but one side there will be an arrow. For an entity which has one, that will be having arrow, that's it. Now we will see one to one. Here boy marry girl, then definitely boy will be one side, girl will be one side. To understand this one, you just ask boy one question. Since it is married relationship, a boy marry how many girls? So a boy can marry at most one girl usually, correct? I am taking a usual case. Similarly, a girl can marry at most one boy. That's why it is one to one. Since answer we are getting at most one, then it will become one to one, right? So when can it will become many to many, I will tell you. Example, whenever a boy B1 has an entry in the relationship I am talking about, if B1 is associated with girl 1, then again B1 is associated with girl 2, then this is definitely not one to one. Then it will become, see, one boy is going to marry multiple girls. That's why it will become one to many so far. But if same way, if B1, B2 is associated with G1, B2 is associated with G2, if you see now from right side, every girl is also participating multiple times. That's why that side also many, right? It will become many to many. So by seeing the data, we can easily answer this question. At this moment, it is one to one because every boy can marry at most one girl, every girl can marry at most one boy. So here if you see student versus course, usually a student can enroll for multiple courses. You get this kind of data. Let's say students are, let's say numbered 1, 2, 3, so on. So 1 comma C, 1 comma C++, 2 comma Java in that way, correct? Similarly 2 comma C, right? So 3 comma C++. If you see this data, so one element 1 is mapped to so many courses. Similarly from right side if you see, so one course may be mapped to multiple students. That's why this is many to many. See here, many and many. So it is many to many. Now we'll see this one, instructor guides students. So here one instructor usually guides many students, correct? Example, there is an instructor called I1. He will be guiding student 1, student 2, student 3. But each student will be participating at most one time, correct? That's why I can say that one instructor guides many students, but each student will be guided by at most one student. Each student will be guided by at most one instructor, correct? If you see the data, you understand it clearly why it is one to many. See here, let's just write the data I1, I2, I3. Let's take 3 instructors and some set of students. Then try to write the relationship between them. So we know how to record the relationship using relation form or set form, correct? Like this, I1 to S1, so I1 to S2, let's say I1 to S3, correct? Similarly, I2 may be instructor to student 4, correct? So that's it. I3 may be instructor to student 5. If you see this data, you can easily understand that. So one element is mapped to many elements. but this side each element is mapped to at most one element, correct? It will become one to many. So in that way you can understand about each and every mapping cardinality, right? There are four different kinds of mapping cardinalities finally: one to one, one to many, many to many, many to many. So we are going to represent them in ER diagram. Whenever the relationship is one to one, put arrows like this, two sides. Whenever the relationship is many many, then don't put any arrow. So arrow represents one. So here instructor versus students, then it is one, instructor side is one and student side is many. Okay. So in that way, so easily we can understand this mapping cardinalities. Now we will see participation constraints. So how to record participation constraints and what is actually participation constraint? So in relationship, generally participation constraint is nothing but how many people, that means whether all the, example take this one, whether all the boys are going to participate in the relation is the question. For that there will be two answers, no, otherwise yes. If for this question answer is yes, if all the boys are participating in this relation, then such relationship is I can say that on that relationship boy or otherwise these boys are participating fully. That is called total participation. Sometimes what happens, every object may not be participating in the relationship, that is partial participation. Now we'll see for everyone whether it is total or partial. So boy is marrying a girl is, every boy need not marry a girl, right? That's why it is partial participation. Similarly, girls also not marrying, girls also need not marry some boy, correct? That's why it is partial. Now come to enroll. In enroll, so every student is enrolling for the course. So it depends on the discussion and depends on the courses, depends on the institute, everything, right? So we assume that, let's say in this institute every student has to take compulsory course, at least one course. If that is the condition, then student will become total participation, right? Similarly, there are some courses, it depends on the discussion. If let's say there is a course which is not taken by anyone, because the reason is, so that is very difficult to understand, then this course will become partial participation in that way. So here instructor guides students. Usually in general case we'll talk about instructor, usually every instructor need not guide the students, correct or not? But in every student should be guided by instructor generally, correct? So that's why I can say that instructors are generally will have partial participation and students will have full participation, and it depends on the college, again university and their policies. So we have to put some assumptions first of all, because we don't know the information correctly about this data. Someone is going to provide the data about their own information, correct? That's why at this moment we are just designers, so I don't know clearly about instructor, correct? So if I know that every instructor has to guide at least one student, otherwise why to take the salary? If that is the argument, then instructors will become full participation. Finally it depends on the agreements, otherwise discussions. Finally you understand what is total participation and partial participation, right? But how to record it in ER diagram? In ER diagram, whenever there is a total participation, usually, example, let's say every student is taking at least one course, right? That means every student is taking at least one course, you put like this, double line. Okay, so this is the representation of full participation. Similarly, every course need not be taken by enroll, right? Then you don't mention. Here let's say we assume that so here every instructor has to guide at least one student. If that is the case, and every student has to guided by at least one instructor, then it will be full participation at both ends, correct? So this is the way we represent. So finally we learned mapping cardinalities and participation constraints and how to represent them. Okay, let's talk about weak entities. So weak entity is a kind of entity which cannot exist without some other entities, especially they are called strong entities. So we'll see such entities. Consider the strong entity employee. So we take some necessary information of employee through attributes employee ID, employee name. So this employee is going to I can say that take the policy, right? Whenever this employee wants to take policy, so policy is a relationship, because so whenever employee takes policy, then when what something happens to this employee, then the amount will go to, so there will be amount, right? How much amount he is going to pay for the policy. Otherwise, so what is the policy amount, total amount he's going to get once, this, I mean, something happens to that employee. So such policy is a relationship, I can say, because so it is not a separate entity again. Employee is going to take policy on some dependents, correct? Now focus on these dependents. So every dependent will have some name and age, everything. Example, let's say Mr. Raju is a dependent and his age is 75. Now just think about him. Raju is a dependent of whom? Definitely here, but whenever there is an employee, we never ask. So it is an independent entity. We never ask this kind of question. But here in this dependence we are asking Raju 75 is dependent, but dependent of whom? So one particular employee. That's why remember one thing, usually weak entities cannot exist without that strong entity. So there is no meaning to dependent if there is no employee, correct? Who is paying the policy. That's why we say that this is a weak entity. Its existence depends on the employees. Example, let's say employee 1 Rakesh is going to pay some policy and the dependent is Raju, 75, like this. Suddenly if Rakesh 1, let's say this policy is company dependent, that means company is paying this policy on behalf of employees. Once let's say this employee leaves the company, then their company policies simply they cancel this dependent. That means there is no meaning to dependent, correct? So they don't bother about this Raju 75 if Rakesh leaves the company, isn't it? So we say that. So that's why again this is one more symptom for checking whether something is weak entity or not. That's why simply delete a strong entity, automatically some of the weak entity tuples will be deleted. That's why I can say that here employee is a strong entity for this weak entity. That's why whenever you are deleting some of the employees, corresponding dependents are going to be deleted, correct? So remember that. So now this policy is called identifying relationship, because every weak entity should be identified, recognized by some strong entity, correct or not? That's why through relationship, remember it, one necessary condition from now onwards, every weak entity should be recognized or identified by at least one strong entity, and for that it should participate in the relation. So that's why this is a such relationship, correct? Now this such kind of relationship is called identifying relationship. Identifying relationship. So this is identifying entity. Otherwise, I can say super entity, otherwise strong entity. This is strong entity. This is weak entity. And participating relationship or otherwise strong relationship. Usually this kind of relationships are represented by two rhombuses, like we have to write 2 times rhombus, that's it. Okay, so now one more thing, see, this dependent's participation should be full participation. Every dependent should participate in the relationship. Why? Imagine this situation, there is some person name is, let's say, Mr. Ramesh and age is 70. So we'll ask Mr. Ramesh, are you going to participate in the relation? Then he said no. If he doesn't participate, that means what? How he can be dependent of some employee? Then definitely he is not dependent of an employee. So Ramesh cannot exist in this dependence if he is not dependent of any employee, correct? So that's why it's not meaningful to have this kind of data. So that means we remove it. So finally, this dependent should participate with total participation. That is what I would like to say. Now these 2 rules you should remember. Of course, you know that, and they are easily convincible. One is the owner entity set employee and the weak entity set dependent must participate in one-to-many relationship set with one or more entities. That's quite obvious, right? Definitely dependent first of all should participate in the relationship, and it should be one-to-many. Why it is one-to-many, I will tell you. Every employee can have, that means the strong entity can have many dependents, right? Many weak entity values. But every dependent should participate with only one employee. That means one dependent cannot be dependent for multiple employees. That is the idea. So that's why it should be one to many. So which side is one? So employee side is 1, remember. So next one. The weak entity set must have total participation in the identifying relationship set. That's quite obvious, we have seen, that's fine. This dependent should be in total participation. Now here I would like to mention one more point. Actually these ER diagrams are loosely defined. That means the syntax is loosely defined. So we use these two rhombuses, right? So some authors use, thick line, that's it. Only one rhombus, but which is thick like this. And they say this is a symbol for strong entity. Not only that, there are so many things like, we use double line, right? But there is one more notation that is using one line but thick. So when in the exam or wherever you see the ER diagrams, you should understand that there are multiple notations. Depends on the discussion. Somehow you have to capture it. That would be good rather than being rigid. That means if you rigid, then what happens? You don't understand others. So if they change any syntax or whatever, you can't understand. That's why don't be rigid. So try to understand and remember this thing in mind, so automatically you can understand. That means there are multiple ways we can define syntax. That means, example here, this may be thick line, otherwise two lines. So if you are able to understand, so that it will be easy. Let's talk about class hierarchies. So what is class hierarchy? Sometimes, you have some objects, set of objects like employees. So it is so natural to classify them into subparts. Example, let's say these employees can be classified into two parts. One is, let's say, full-time employee. Second one, let's say, part-time. That means, let's say, part-time. Correct? So there can be two kinds of employees, right? So in this model, we say that we are classifying employees into two. Similarly, for some other entities, there might be multiple I can say subclasses. So from now onwards, I say employee is a class, and that further classification whenever you do, that sub entities are nothing but subclasses. So in object oriented terminology, we use subclass and subclass. So here it is entity and sub entities. Okay, both are same. Now when you have such kind of classification, how to represent? Yes, we can even represent in ER diagram. We will see that. So we know how to represent your superclass, right? Employee. Superclass is nothing but for me main entity. So this employee will have employee ID, so employee name. These are the features of every employee, correct? That's why I am writing these attributes or features here. So there are some features which are special to that subclasses. Example, so how I represent this classification or class hierarchy in ER diagram is like this, triangle. So here you write one classification. So this is not compulsorily to be a triangle. So you can have, polygon, any polygon. So here what we do is we write like this. Now employees are full-time employees, part-time employees. So in full-time employees, again don't write employee ID, employee name, because already they are implemented in employee, correct? So here we implement only. So the essential features, what are the essential features which describes full-time employee? Every full-time employee usually will have salary, right? So every part-time employee will have usually something wages, otherwise hourly salary, correct? So hourly wages. In that way we can differentiate full and part-time, right? So we write here the hierarchy name. Employee is a full-time employee, employee is a part-time employee. So this is called, hierarchical classification, otherwise class hierarchy. So here employees are finally specialized into full-time and part-time. So this is one way of writing. There is a second alternative way of writing. So first we begin here and we go to employees. That means, so you have two entities I can imagine. One is full-time employees, second one part-time employees. Okay. So full-time employees has some feature salary, we know that, we copy it, and part-time has a feature hourly wages, let's say HW. Now we can do like this. Full-time employees and part-time employees all together will become employees. So this is another way of writing the description, employee, and after that features, employee ID, employee name. Both are same, so there is no difference. But we are coming from top to bottom. Here it is bottom to top, right? Reverse, quite reverse. So one more thing is, so why this classification is required? So I can explain this with this relationship. Consider this relationship. So manage. So this manage is a relationship which is mapping full-time employees and projects. That means only full-time projects has to manage the projects, but not part-time. If you have this kind of classification, then we can have some specific relationships and we can carry them among the subclasses and some other classes, correct? So that's why I can say that when you have this classification, this kind of relationships will be easy to recognize and identify, correct? But when you have just only one class employees, then it will be difficult to have this kind of managed relationship, because only few employees, that means only specially full-time employees in this employees are going to participate in the relationship, not this part-time. Then it is definitely good if we have this classification and it is easy to see here, correct? That means only full-time employees are having this property or this relationship. That's why we will maintain hierarchy. Now this hierarchy, otherwise these subclasses, are having two properties. One is overlapping property, second one covering property. I will tell you what is overlapping property. So these subclasses, whenever you divide, that subclasses may, what is the overlapping properties? So there may be some element, employee, that belongs to full-time and part-time at a time. But in this case, it is not possible. Let's ask this question. Every employee is either full-time, otherwise part-time. But is there any employee who belongs to full-time and part-time? Generally, no, right? So then we say that employees, full-time and part-time are non-overlapping subclasses. But there are some subclasses, in some classifications. So there will be common elements. Let's see such kind of things. Example, let's say. So these are all, I can say that employees, let's say. So these employees are divided into, classified into two parts, so that this one classification is like this. Let's show like this directly. Employees are classified into the employees who play cricket, cricketers, and employees again classified into cricketers and let's say tennis players. Okay, tennis players. Now see, there may be an employee who play cricket and who play tennis. Then so here this classification is overlapping. Then when you don't mention in ER diagram anything, then the default is they are non-overlapping. If you want to say that they are overlapping, then we write like this: cricketers. So that means we write cricketers. So we don't write anything on picture, we write just side of picture anywhere. So we write like this: cricketers. You want to say overlap, right? You write like this: overlap tennis players. That's it. So this is the syntax for writing to mention that cricketers overlap tennis players. Now we'll see covering property. What is covering property is, example, whenever you have a classification, this is superclass, subclasses, right? So this superclass is covered by all the subclasses or not. So here example, every employee belongs to either full-time or part-time, yes or no? Yes, that's why we say that employees are covered by this classification. Now we see this one. So here employees are again classified into cricketers and tennis players. Let me ask same question. Every employee is either cricketer or tennis player. Is it true? Need not be, right? There may be employees who does not belongs to cricketers and tennis players. So that's why I say that here there is no covering property. These cricketers and tennis players are not covering employee, correct? So default is actually not covering. That means if you don't mention in ER diagram so anything, then default is like, example, this is a ER diagram. If you don't mention anything, then we assume that, let's say, this subclasses doesn't cover employees. But if you have to mention, if you want to mention that, so here example in this one. So full-time employees and part-time employees are covering employee. Then how to write it is, this is the syntax. Full-time, right? Full is the class name and full and part-time covers, correct? So cover employee. If you write like this, then we can understand that there is a covering property. If you don't write it, by default is non-covering property. So this is about mentioning covering property and overlapping property or overlapping conditions. Understand? So we learned finally about class hierarchy.